Welcome to Common Base Amplifiers Review. All right, so we can identify this amplifier as having emitter biasing or two power supply biasing. And that was covered earlier in the semester, and I'm going to post the video alongside with this one. But right now, we just want to focus on the common base amplifier. And so we know we want to look for our gains. So we know AV is equal to V out over Vin. Now we can derive this formula using some of our currents. So we want to go next step would be I out. Our V out is going to be equal to IC times RC parallel with RL. And our V is in a common base is basically right here. We can see that with this cap C1, we've basically got an AC ground right here at the base of this transistor. We bring that across. We've got it's 0 brought across, but we still have R prime E right here. So as long as that cap is there, there's no resistance to bring across. We've got an AC ground. So our IN is, or our VN is going to be equal to IE times RE1 plus R prime E. Now we can simplify that a little bit more, and we know that IC over IE is equal to alpha, and then we can put that in terms of beta. And we've got AV is equal to beta over beta plus 1. That times RC in parallel with RL divided by RE1 plus R prime E. And that will be our voltage gain. All right, so now that we've got our voltage gain, let's go ahead and do our Z in and Z out. That'll help with our AI. So let's look at Z out first. If we look at the we want to look at the impedance that the load sees for Z out. So Z out is going to be equal to RC. And Zn is going to be the impedance that the generator sees. So Zn is going to be equal to, we can see again, we've got C1, so that's acting like an AC ground. And if we bring 0 across the beta barrier, we still have 0. So we've got this R prime E right here. So we can see that our Zn is going to be R prime E plus RE1. Those two in parallel with RE2. And that gives me Zn and Z out. And while we're here, we could go ahead and do our AI. So we know that AI is I out over IN. We can translate I out to V out over RL, because we're interested in the current that's through the load. And our IN is the current right here at the generator. right where our eyeball is. So there's our IN. So our IN would be found by calculating VN divided by ZN. If we manipulate this formula, we get V out over RL times ZN over VN. And that can be simplified down to AI equals V out over VN times ZN over RL, which equals AV times ZN over RL. There's your AI. So if we want to calculate AP or our power gain, it's simply AV times AI. Okay, so now let's finish up our load line. We've got our DC load line from before, and we need to get our AC load line. We know we've got our Q point, which is VCE, comma IC. So our AC load line is going to be equal to, I get something like this. Here. So we know we've got 2 points that are important here. VC AC cutoff and IC AC sat. And our IC AC sat is equal to VCE divided by RC in parallel with RL plus IC. And our VCE AC cutoff point is equal to VCE plus IC times RC in parallel with RL. Now with this information, we can figure out what our V out max peak is. And what you want to look for is you want to see which side is bigger. Where our AC is going to operate around the Q point right here. And we want to find out which side clips off or cuts off first. So we know that it's going to be the smaller of the two. So it's either going to be VCE, which would be right here. Pick a different color. VCE, which would be right here to here, or VCE AC cut minus VCE, which would be right to here to here. Whichever one of those is smaller. So our V out max peak is going to be out VCE or VCE AC cut minus VCE. Whichever one of those is smaller. Now we know we can solve for Vn max, and Vn max peak is going to be equal to V out max peak divided by AV, our voltage gain.